Don't come back in. I'm not too worried about it.
Yeah.
I'll keep sending him invites just to make sure you can get back in.
Okay.
So were you able to go over this week's material?
Yeah.
Yeah. And did you
Half an hour ago. Super
half an hour?
Lucy, you can have chicken
No.
if you eat your noodles.
Did you go over the group assignment yet?
Don't yell.
Have you looked at that?
The group assignment?
Yep. What we're turning in tonight. Oh, hold those back. Okay. Well, then let us get started. Welcome back, Pablo. You ready to go?
Oh, thank you. Yeah, can you guys hear me?
Oh, hey, that's a lot better.
Yeah.
Okay, perfect.
Excellent. Hey,
Perfect.
you don't sound like a robot anymore.
Okay, I kind of sound like it on my end, but I'll just live with it.
Okay. All right, so extension. Fill out the table. I didn't even look at the table. Okay. Do you guys just want to go straight into the extension problems, or do you want to do the team discussion portion of this?
Either way, I mean, as long as you did the prep, the discussion, it was all there. So,
Okay.
but if you guys want to go over it, then I'm fine with that.
On my end, I'm pretty good to go into the extension.
Let's go straight into the extension then. I didn't do it, but I'm pretty confident in the material, so I'll go back and get it later.
Okay.
All right, so it says find the following values. Try not to use any resources outside of us. Be sure everyone in the group does at least one. So do we want to just round robin down the list?
Yeah, that's fine.
Okay. So I can go ahead and go first. Tangent of 5 pi over 6 is negative square root of 3 over 3. And then Elise, you're on the left side of my little monitors. So can you do the next one?
Sure. So, with any problem that's like similar to f of x, you're going to take what's in the parentheses first. So we're going to look at the inverse of tangent of 1 over square root of 3. I haven't done these yet, so I'm not going to be as fast as you guys probably will.
That's okay.
But and calculators don't count as like a resource outside of the work, right? Just to make sure.
You know, I've never been sure because some of the questions they tell you to use the calculator. That you can't get the right answer otherwise.
I don't feel like calculator really counts as a resource. I think that's talking about like notes. So you put in the inverse of tangent into the calculator and it comes up as 30 degrees. So then you get the cosine of 30 degrees, which is, I don't have my unit circle, which is a resource anyway. There. So that one's square root of 3 over 2. Is that right?
That's what I have. I'll be honest, I just had my calculator do it.
Well, that's comforting because I got that one right. Makes me feel a little better.
All right, so Pablo, you got the next one.
Yeah, so I see inverse sine negative 1/2. Just with the unit circle in between negative pi half, also pi half, and the answer is negative. And I wrote it down here with the unit circle. It's negative pi over 6.
That's what I got as well.
Okay.
Elise, do you agree with that?
Yeah.
Yeah. My turn. So cotangent of 9 pi is, I actually did not get this one right. So I wrote down, I used a calculator and it gave me like a decimal, despite being in radians. So correct me wrong if I'm wrong. To get cotangent, you look for where you try to find where tangent equals 9 pi, right? And the angle of that tangent is no. So how do you
No.
get cotangent?
So cotangent is 1 over tangent or cosine over sine.
Okay.
And 9
Yeah,
pi
I use the
is
cosine over sine method.
yeah. So 9 pi is that when sine is 0, or is that? I want to say that when sine is 0.
Well, 9
So
pi,
that would be 0 over 1, right?
right? It would be 0 over negative 1, right? So
Oh,
it's
yeah.
sine over
Okay.
cosine. So it would just be 0.
Well, it'd be cosine over sine, wouldn't it?
Which would make it
Yeah.
For
undefined.
cotangent.
Yeah, so that one's undefined.
Well, that explains why I couldn't get a right answer. Okay. So at least you have the next one.
Yeah. So cosecant is just 1 over sine. So really we're looking for 1 over sine of negative 11 pi over 3.
Let me get you some more food, okay? Be right back. Okay. What happened?
I don't know. What happened?
Which
Sorry.
is
I realize I just spoke into my mic. I'm talking to my daughter.
good.
What happened?
Sorry. I'm just
No, you're
looking at that. Okay, so that's 1 over sine of, it'll be the same as like 60 degrees,
Hi.
which is 1/2? No. On my unit circle with me, sorry. Is that right? Is it 1/2 or am I off?
No, you're off. It is,
It's,
you're looking at the x, you need the y. You're looking at cosine.
Okay.
I think you're on the right track. You're just looking at the wrong number.
Well, I was just I was half guessing because I don't have my unit circle with me. Now I'm
Oh,
looking
dear.
at it. Pulled it up. I can hear you. It's not. I don't have it with me. Okay, so that one's 1 over. So that's 2 over square root of 3. There.
Is that what you have, Pablo?
I got 1 over square root of 3. I could be wrong. I could do it again.
1 over square root of 3.
Let me do it again.
It's pi over 3. Y is square root of 3 over 2. So it's 1 over square root of 3 over 2.
Yeah, that's what I have. Like,
So it would be 2 over square root of 3, right?
Right.
Which is also written as 2 times square root of 3 over 3. For whatever reason. I don't know why that is. And you're reading this particular. Okay. So Pablo's turn, right?
yeah. I was just looking, so the next two are actually exactly the same.
Yeah, I noticed. I think
Yeah,
it's a
so
typo.
yeah, probably the sine of negative 5 pi over 6 is, and it's just a unit circle again, just going down, and we can get negative 1/2.
Yep, I have that as well.
Alrighty.
Okay, I actually did not get the next one.
Yeah, I was just trying to do it right now. 5 pi over 4.
I want to see if I can do this one.
I'm not sure what it is um, in a better form, but I found a decimal version. Yes.
Would it be pi half? Or half? Yeah, pi half.
I didn't get pi halves.
Ah, okay. So you both have pi over 2.
I got pi over 2.
What'd you get, Elise?
I mean, I didn't get pi over 2. How did you guys get pi over 2?
The way I did, I just started from looking at seeing the unit circle of 5 pi over 4. And the cotangent of 5 pi over 4 is 1. And so we look for the cosecant of 1 since we have the cotangent of 5 pi over 4. And I found it to be pi over 2, but
You're looking for cosecant of 1,
yeah.
but it's asking for the inverse of cosecant of 1.
So
Right?
cosecant is the inverse of sine.
Yeah,
Is
but it's
that
got a
right?
negative 1 above it, which means it's looking for the inverse of
Oh,
cosecant.
yeah, right.
Right.
And they give you a formula for that. So
Oh, that's right.
if I got
A formula for what?
there's a section on arc sine, but
Oh, okay.
maybe it's just tangent because the only one up there. Well, if it's the inverse of cosecant, it should just be sine of 1, right?
Sine of.
No, I don't think so. Maybe. I don't know. Wait. So what you guys are saying, I'm just trying to understand. So you're saying that the cosecant inverse of 1 is the same as saying sine of 1? Is that what you're saying?
So normally it would say sine raised to negative 1. In this case, it says cosecant, which is already the inverse of sine. And then they raise it to negative 1. So they want the inverse of the inverse.
Right.
Wouldn't that be the just sine itself?
That's what I would
It
think.
wouldn't. No, it wouldn't be, because if you take this, for example, if you take the inverse sine of 1, then it's 90. But if you take 1 over sine, which is cosecant, right? Right?
Mhm.
Of 1, it's definitely not 90. They're not the same. Just to give you an example.
Hold on, sweetheart. Hold on.
That's just how because when you put it in the calculator, they're not the
Can you give me
same.
a second? Okay, I need you to be patient with me. I'm in the middle of a sentence, okay? No.
If I get I think I have 2 over pi.
Oh, so just do the inverse.
Because you're just inverting the pi over 2.
That's what I got too.
Okay.
Is that what you got?
Okay,
Hey,
yeah, that
do you
makes
see
sense
Dada
now.
has headphones? Has headphones. He's in a class right now. Like his computer.
So everyone's in agreement on that one?
Computer, the pictures.
It's 2 over pi?
Right now, Dada is in a class.
Yeah.
Yeah. Is that right?
So right now, Bobby is helping Lucy.
Okay.
Right now, Bobby is
So
helping
then on
Lucy.
page 2, they give us the 2 triangles.
No, Bobby is helping Lucy. No, Dada is doing homework. Bobby is helping Lucy.
So we're
Okay, so
looking at dimensions now.
Yeah, so the left triangle, we're
listen to
we're
this.
finding out all the lengths and the angles.
The dimensions of
And
most
he
jobs
wants us to know, or to list how we got each piece of information.
are straight.
Okay.
So looking at the left one, we have the information for one angle. We have a 90 degree
Only by the body.
and 2 sides. So the first thing we could do is use Pythagorean theorem to get what B is.
Mm-hmm.
That side B is.
Yeah.
I'm trying to figure out where I could write this one. It's still going to look nice and neat.
Okay.
So you have 6 squared, 15 squared, and then B squared. 6 squared plus B squared equals 15 squared. Okay. B squared equals 36. Negative 36. I did that backwards. Negative 36 plus 225 or 225
What
minus
can I do for you? May I eat this? Please.
and then you square root that.
Can I eat that?
So B equals 3
Can I eat that?
times the square root.
Oh, thank you. Oh.
I got that too.
What'd you guys get?
So B equals 3 to the or 3 times the square root of 21. B the side, not B
Lucy,
the
you
angle.
didn't want to eat it?
3 times the square root of 21.
Mommy, eat it?
So that's the length of B, the bottom side.
Okay, that's what I got. Were we supposed to get it in that form or?
Yeah,
Okay.
because we're using trigonometric functions. We try to do everything in radians.
Okay.
So, and then we're given an equation in 5.6 where it's supposed to be for non-square triangles, but it works for square triangles
Only
too.
one.
You know what I'm talking about, where it says sine of A
Yeah.
over A equals sine of B over B. So I use that to get the angles B and A. And then I just double checked it, doing the whole, all 3 angles equals 180.
So what I did was just do the inverse sine of opposite over hypotenuse. So
No, only
6
one.
over 15 inverse sine. I got 23. And there 23.37.
See, I think I tried to do that and my calculator wouldn't do it. So I gave up. What'd you get?
No, only one.
For alpha, I got 23.378. And then I just subtracted that. 180.
378.
Yeah. So then I subtracted that from 180 and then 90 from 180 to get beta, which is 66.6.
Okay. Elise, do you agree with that?
So tell me again how you, like what method you used.
So I just learned previously like GHOA.
Mm-hmm.
So in order to get an angle, like I'm looking at alpha angle, you can use sine or inverse sine opposite over hypotenuse. So 6/15. And it gave me 0.4. So inverse sine of 0.4 gave me the angle.
Cool. Yeah, that makes sense. When I looked at this, my first thought was law of cosines, which I'm sure you get the same answer as you do with SOHCAHTOA.
I did the law of sines, and I'm within a decimal point of problem.
Yeah.
Or within a tenth of problem.
Cool.
Let's see where I thought. So Elise, what did you get when you did law of cosines?
I haven't done it yet. That's what I thought when I looked at it. I can do it though, real quick.
Why don't you do it to double check?
Yeah.
I'm really close to what Pablo has, but I want to make sure that we all agree. One second.
Where do you think you're going? Hey.
So law of cosines, if you're not starting out with c squared,
Here, I'll take it, Lucy.
I'm having a hard time finding the formula for whenever when you're trying to find. Oh, never. I found this.
You got it?
Yeah.
Pablo, what was the number you got for alpha?
What did I get for alpha? 23.78. Close to that. Degrees.
23.37.
Yeah, I can do
Check
it.
the math here.
Oh, 23.57.
Yeah.
5, 6.
Yeah, time to take it back.
Oh, that's exactly what I have. Okay.
Okay, perfect. Yeah, I think I wrote it down wrong.
And I wound up just rounding to the hundredth.
You can use law of cosines in this, actually.
Yes.
It took me a little too long to figure that out, but
Oh,
you
that's
can't
okay.
because all you know are the sides and one of the angles. So law of cosine you can't do unless you know two angles.
Right, but if we do alpha, then we have two angles. Oh, I guess I see your point. Sorry.
No, you're good. So yeah, I guess the first thing that I would do after law of cosines is do law of sines. Or SOHCAHTOA. And you guys got hold on.
Whoa. Pablo, is that coming from you?
Can you still hear it?
Someone's mic is tripping.
I can hear it, but I don't know if it's mine doing that. Let's see.
My little sound bar
It
says
might be
it's
you,
coming from
Andrew.
you. No, it's not me. You got it. Let's stop. Ah, that's
Okay,
good.
it's over. That was loud.
Yeah, that actually hurt. Okay, so for beta, even though we can subtract beta from 180, we know the other two. I went ahead and did log signs just to double check my math. What I wound
Did
up
you get the
getting,
same?
I got the same answer I would have gotten if I had just subtracted it. And it was 66.42. Does that sound right?
That was for
For beta, for B in the top.
let me see. Okay, I'm sorry. What did you get?
66. You asking Pablo or me?
Either one of you. You got 66 for beta?
66.42 for beta. Is that right, Pablo?
I got that.
You got that? Pablo, did you mute your mic to solve the problem? He's muted. Okay, hold on. Opening chat. Pablo just lost his mic.
Oh,
Okay, so the second triangle, we're given 2 angles and 1 side, which fortunately means we can use law of sines. So where did I start? I don't remember. This is like 3 hours ago. I did A. So for side A, I just did, because you're given the 90 degree and then the hypotenuse. So I use that as my ratio for the other 2 sides and angles. I think. Yes. Looks like that's what it
yeah,
is.
makes sense.
Oh, that's what it is. I got B first. Okay. I lied. Let's sign the B first.
Did you get B?
Yeah. So B was the first thing I did.
And what'd you get?
I have 3.03.
For B?
Is that what you got?
No.
I kind of figured.
It's not. No.
Judging by the tone
I
of your
put
voice.
in.
Okay.
Yeah, no, I put in 20.5 instead of 28.5, so that was my bad. Let me try it again, make sure.
Yeah, I still get 3.03.
Yeah, I did too. So there's that one, and if we know that, then we know all of the sides, because we can just do Pythagorean.
Yep. Although I think I went ahead and did the law of sines just to double check my math because it was faster for me than doing the Pythagorean's theorem. We can do it that way too. Ooh. Ow. So for A, do you get 5.58? Is that right?
Yeah. I think so. Yep. That's what I got.
Okay. You keep it up, Pablo? Okay, he says that's what he's got to. Good. And then to get angle alpha, we can just subtract 28.5 from 90 degrees, or we could do it the long way. But it's easier to do the short way. So I tend to like to do the short way. Just as 28 minus 90 and minus 28.5. With alpha. So alpha equals 61.5 degrees.
Yep.
Yeah.
That's what I got.
Okay. Next one's fairly easy too. Actually,
The guy wire.
yeah. Draw yourself a cell tower and a guy wire, or you could just draw a right angle triangle. It doesn't matter. It depends on how artistic you want to be. So first question is, let's see, yeah, what would you like to have answered and could be answered from the right triangle?
Not knowing anything at all about it other than that it's
Yeah.
a right triangle.
All you know right now is that it is a right triangle.
Well, I mean, there's only so much that you can know from a right triangle that's not labeled. All we can know is the one angle.
Right.
So, but any questions that you might have would be how far away I guess how far, I'm not sure how to word this, how far the elevation would be from a certain point. And that would tell you the
Right, so you're
bottom
asking for the
side.
angle of the guy line at the anchor.
Yeah. So, okay, that question would be the angle. And if you have that angle, then you have the other angle too. But also you could ask how far away from the wire someone is standing, and that gives you the bottom side. And with that, you can solve the whole triangle. Right?
Right.
Yeah.
So, sorry, I have to write it out. Distance from tower to guy line, or I've got a triangle labeled here, so I'm putting the labels. And then we would also like to know elevation of the guy line. Or to know angle, and I have angle Bravo there. And you're right, with just those two numbers, we can solve the triangle. So then the next part of that question, Pablo, do you have anything? Oh, he's gone. Okay, never mind. Let me see if he wants to get back in. Him and Adrian are always in and out. Okay. So then it gives you, the angle of the guy line and the distance. Oh, it gives you the height of the cell tower. Okay, it's not nearly as fun.
So we're saying it's 125 feet?
Yep, so the height of the tower is 125. That's in feet. And then the angle at the bottom, where the guy line is 32 degrees. So we know two angles and one length.
Okay. And so it's asking how long the guy wire is, right?
Yeah, that's the only thing it wants. And we can do law of sines. Once again, I really like using that through this whole thing.
Can you guys hear me now?
Yeah, welcome back. Although I've just got audio, I don't have a picture of you.
Oh, perfect. Okay.
Yeah, is that just the way you like it? All right, so if you're keeping up, Pablo, we're working on the cell tower question.
Okay.
We're working where they've given us the height and the angle. So I did, I'll just write that in. So I have 235.9 feet, or basically 236 feet.
I got that too.
Did you? Pablo? Still with us? Maybe not. All right, so the next question asks, does that cell tower fit within the 210 feet between the tower and the edge of the road? The answer is no, it would not. Actually, no, that's not true. I don't know.
That's what I was about to say.
I lied. Just kidding.
I mean,
So now we have to
'cause that
figure out
would
what
be
the
200. What do we have to figure out?
now we have to figure out what the base of the triangle is. Because we know the guy line is 235 feet, but that doesn't necessarily mean that the base is 235 feet.
So, yeah, I got 200.4 for the base.
Did you?
Yeah.
Okay. I will trust your judgment.
Okay.
Okay, so it would fit.
Yeah.
What did you use to find that?
Just law of sines. Because we had the top angle was 58 degrees, and we had the side of the triangle that's opposite of the 32 degrees. So you can just plug that into law of sines and find that. Just the 125 over sine of 32 equals the base over sine of 58.
Very good. Okay. So moving on, we have the picture of the water tower. This one took me a little while. And I had to go back and look. Which stinks. Oh, no, look. All right, so you would like to know the height of the tower. You begin walking away for whatever reason without counting. Just a little bit beyond me. You stop, you measure the elevation at 23.5 degrees. You walk 50 more steps because now you remember you're supposed to be counting. And the angle is 19.5 degrees. If train A and train B are headed towards each other at 35 miles an hour, approximately how high up is the moon?
Right.
Yeah. Okay, so initial distance, that was the mark as X.
Are we trying to find just the height and the x, the initial distance?
You just need to know the height. That's all it's
Just
asked
the height?
for. Yeah.
Okay.
Yeah, all it asks for is the height of the water tower. In the book,
Okay.
there is a question that's identical to this. And they do a whole bunch of proofs that I didn't read.
I mean, there's a question just like this on the quiz we took Saturday. By Saturday,
Is that?
I guess.
I don't remember doing that. Maybe I didn't work as far as you did.
I don't know.
Quizzes seem to take forever for me. All right, so having done the quiz, do you remember how to do this?
Yeah, I do. Did you already do this one?
Okay. Yeah, but I cheated. I pulled the formula out of the book and just plugged everything into the formula.
Yeah.
So I know what the answer is, I just don't know why it worked.
So, So you've got the drawing where you have a right triangle, and then the
Right.
triangle right next to it.
And then
would
a little
connect,
tiny
right?
one.
Okay.
Yeah.
So you know the angle of elevation in the beginning was 23.5, and that's right, not the right angle, but the angle on the right.
Right.
On the
It's the first one before
triangle.
you started counting.
And so you just subtract 180, or you subtract that from 180, and that's the angle on the left of the other triangle connected to it. You know what I mean?
Okay.
And so once you have that, and you have the other angle on the right, which is 19.5, you can find the angle at the top of that triangle, which is 4 degrees. And so once you have that, okay. Let's see, how do I do this?
Hello?
Hello.
Hello?
Hello.
Hey, Pablo.
Hey, you guys.
Having some trouble.
Yeah,
your
a
mic?
little bit. I don't know what's happening.
I'm sorry.
Hey, your mic's working
It's like
perfectly now.
Yeah, no, it's good now, but
Okay, good.
Just don't go Terminator on us again.
so
Where are you guys right
we're
now?
looking at the
Water
water
tower.
tower problem.
Water tower? Okay.
Mm-hmm.
You need us to go back? Or are you good?
That's okay. Yeah, I was with the telephone tower. Are you guys on the second bullet, or I guess it's just one.
That's all one. So Lisa's telling me how she did it, and it's different than what they try and get us to do.
Oh, this is different than it is in the book?
Yeah, you did something different. So I'm interested to see how you did it and what you got.
Yeah, I'm sure I got the same thing. I mean, it's just basic identities. So once you have that angle is 4 degrees, you can look at the well, I guess you didn't really need to. So you know that the angle on the right angle is 90 degrees, and then the angle to the far right is 19.5, and really the whole triangle. Okay, now I know I did that. So you need to find the all of the sides, the side on the far right triangle. So when you have all of the angles, and you have the 50 feet, you can use the law of sines and find the side that connects the two triangles. You know what I'm saying?
Okay.
So, and I haven't done this one yet.
Right, the dividing line between the two triangles.
Right.
Which would give you the hypotenuse for the original triangle.
Right. Yeah.
Okay. I see how you did it. The way you explain it is a whole lot better than the way that they try to tell us.
Well, good.
Yeah, isn't that comforting?
I'm glad. Makes me feel like I know what I'm talking about. So
you did sine of 4 degrees over 50 feet, right? Equals sine of 19.5 over x, let's say.
Mm-hmm.
And what did you find x to be?
Yeah, I haven't done this one yet.
Oh, you haven't? Okay.
I did this one on the quiz. It's basically the same problem. Yeah. So.
Okay. I pick up what you put.
Here, let me do it real quick, and then I'll tell you what I got. So when I do that, About 239.3 for that measurement.
That's what I got.
For that side. Okay. And so once you have that, and you have all the angles,
So I have 90 over 239.3. Actually, the way you did it is a whole lot easier than what they try to have us do in the book. So congratulations, you found the easier way.
well, I'm glad. Glad I could help.
Well, now when I go to do it on the quiz, I'll know how to do it.
It just seems like the more logical way to do it. I don't really like the way that they explain things in the book a lot of the time.
You hiding from mommy?
Bingo.
Those pajamas are way too big for you.
Alright.
Yeah.
Okay.
Okay.
Mom. Mom.
I have 95.4.
That's what I got.
That's that right?
Mm-hmm.
4, 2 feet. Pablo, you with us?
I'm trying to follow. You guys should figure it out and then maybe explain it to me after. You don't worry.
Sorry.
No, you're good. You guys are on a roll.
95.42 matches what I got using the book's method. So pretty confident that's the right answer.
Yeah.
Could you walk that through with me, just like step by step? How you
Yeah.
guys did that?
So we start out with the picture. Did you already draw the picture?
Yeah, I have a picture here. Someone.
So looking at your picture, you start out with the right triangle,
Okay.
and then you have another triangle just from walking back away from the water tower connecting it, right?
Right.
So we have all of the angles that are at the bottom of the diagram. The first one, 23.5. The second one, 19.5. So, and we have the 50 foot that is connecting those two, like where those two angles are.
Okay.
Right?
Yeah.
So, knowing the angle in the middle on the bottom, if you subtract that from 180, you can find the other angle.
Oh, that's right. Okay.
Next to it. You know what I mean?
Yeah.
So, which is 156.5 degrees.
Okay.
And once you have that angle, you can get the third angle by subtracting them all from 180. So you subtract 156.5 and 19.5 from 180, and you get 4 degrees for that top angle, right?
Okay. Yeah. Uh-huh.
Okay, and do you remember the law of sines?
Yeah. So. Oh, I see. I see what you guys are doing now.
Yeah. So you use the law of sines to find that connecting length between the two angles. Between the two triangles. Through law of cosines, just sine of 4 over 50 is the same as sine of 19.5 over that number that we're trying to find.
Okay, gotcha.
And you do all the math out. Basically, it comes out to 239.3.
Mm-hmm.
So once you have that, and you have all three of the angles, you can find the height of the water tower by using law of sines. So basically, all this problem is you using law of sines, as well as all triangles add up to 180.
Mhm.
That's like the whole thing.
All right. And the book did it differently, you said? Like, I actually didn't even see the books in
Yeah,
the
I don't know
paper.
how the book did it, but it comes out with the same answer,
Okay. So it
just
works
doing
out
it that way. So
all right. Well, thank you.
okay, yeah, no problem. So is that the end of the prep or the instructions or whatever?
Pretty much.
I think that is.
That's all of it.
All right.
Cool.
Well, thank you guys for meeting up. Do we have a time on Thursday already, or were we still just working on that? Or
I don't think we've agreed
you
on
guys
a
want to
time.
meet?
Abby,
Okay.
sweetheart? Okay. We'll have to text about it. I think Thursday is the kind of tight for everyone.
Okay. All right.
Well,
No
if Thursday is
worries.
tight for everyone, I can meet anytime in the morning tomorrow before like 1, or tomorrow anytime after.
Mornings don't work for me. I work a full-time job during the day.
Okay, well I can work after 6 tomorrow.
I can do after 6 tomorrow if you guys want. If Thursday's a little tight, so.
Cool.
I teach scouts from 6 till 7. I can be online at like 7:30. Thank you.
Okay.
That works for me.
We'll,
Does that work?
okay, we'll text Adriana. Let's see if that works for her too.
Okay.
Say hi to you guys.
Hi.
Hey, what's up?
Hi.
Hey there.
What are we doing?
All
Now
right,
that you've
guys.
done
Good night.
She's a cutie. Okay,
Say bye-bye.
well,
Bye.
Say see
Bye.
you later.
Have a
Bye.
good night.
Say peace, ninjas. I'm working on that one.
Bye. Bye.
Bye. Okay.
Okay.
See
Thanks,
ya
guys.
Thursday.